This is a review of your quiz in my class on Big Ideas 1 and 2 and Supporting Ideas 5 and 6. These 4 concepts will take up about 40% of your FCAT. So it's about multiplication and division of fractions and decimals, connecting ratio and rate to multiplication and division, number and operations, and data analysis. We talked about data analysis in class, and it means just analyzing sets of data using the mean, median, mode, and range. Let's look at question number 1. A cookie recipe uses 4½ cups of flour. Write an expression that can be used to determine the number of cups of flour needed to make half of the recipe. All right, here were the acceptable answers. You could have said 4½ divided by 2. Right, 4½ divided by 2. 4½ times 1/2. Or you could have drawn it like this, 4½ divided by 2 with a fraction. I also saw some people do this. They did 4½ times 0.5. That also would have been okay. Let's look at the unacceptable responses. Here's the most common unacceptable response. A lot of you wrote 4½ divided by 1/2. But remember, when you divide by a fraction, it's the same as multiplying by its reciprocal. Do you remember same, change, flip? Keep this the same, 4½. Change the operation from division to multiplication and flip the fraction. So this value is really saying 4½ times 2/1, or 4½ times 2. And that would be doubling the recipe, and they asked us to cut it in half the recipe, not to double it. These fractions and these operations are not equivalent to these. Okay? These mean you're cutting the recipe in half. These mean you're doubling the recipe. Question number 2 says, Miss Feldman has 30 students in her math class. Today she gave her students a quiz and told them they had 15 minutes to finish. After the first 5 minutes, 1/5 of the class had completed the quiz. Over the next 5 minutes, 2/3 of the remaining students completed the quiz. How many students in Miss Feldman's class were still taking the quiz during the final 5 minutes? These units of time don't matter for your calculations, so they're just put there to confuse you. I'm going to scratch them out because it doesn't matter when the students finished. The only thing that matters is first 1/5 of the class finished, and then 2/3 of the class finished. That's the only thing that matters. Let's set up our known and our unknown. What do I know about this problem? 30 total students are taking the quiz. 1/5 finishes the quiz, then the remaining 2/3 finish the quiz. The unknown, I don't know how many students are still working. I need to figure that out. I'm going to show you how to do this in 2 different ways. Method 1 you can think of as the mathematical way, and then we'll look at method 2 later. So step 1, I need to figure out how many students are 1/5 of the whole group of 30. 1/5 times 30 students. When you multiply fractions, you just multiply straight across. So 1 times 30 is 30. 5 times 1 is 5. 30 over 5 is the same as 30 divided by 5. That's simple enough. 6 people finish the quiz. If 6 people finish, how many are left? Well, we started with 30 minus the 6 that finish. We end up with 24 remaining students taking the quiz. Now we're going to figure out 2/3 of the remaining students, not of the original 30, 2/3 of the remaining students, because in the question it says 2/3 of the remaining students completed the quiz. So 2/3 times 24, we multiply straight across. 2 times 24 is 48. 3 times 1 is 3. 48 over 3 is the same as 48 divided by 3. And if you do the division, you end up with 16 finish the quiz. If 16 finish the quiz, and we started out on step 2 with 24 remaining students, 24 minus 16 is 8 students are still working on the quiz. The second method I'm going to show you is graphical. And this is the method that you would use if you read the question and you had no idea where to even begin. So I drew 30 little circles to represent the 30 total students. So I have 30 students taking the quiz and 1/5 of them finish the quiz, right? 1/5 of them finish. I have 6 rows of 5, right? 1, 2, 3, 4, 5. And there's 6 rows. 1, 2, 3, 4, 5, 6. So it's really easy to cross out 1/5 because it's just one column. Those kids finished the quiz. Now these are the remaining students. And it says 2/3 of whoever's left finished the quiz. Well, that's easy too because I have 6 rows, right? So I can divide, this is 1/3, this is 1/3, and this is 1/3, right? So cross out 2/3 of the remaining students finish the quiz. How many are left? 1, 2, 3, 4, 5, 6, 7, 8. 8 students are left. We end up with the correct answer either way we choose to figure it out. Question number 3 says, Bailey is doing her weekly chores, which includes ironing. She counts 15 shirts in the basket of clean laundry that need to be ironed. She irons the first 3 shirts in 15 minutes. If she continues to iron the shirts at the same rate, how long will it take her to do all the ironing in the basket? Let's set up our known and our unknown. What do I know about this problem? I know that Bailey has 15 total shirts she needs to iron, and she's working at a rate of 15 minutes per 3 shirts. Remember, you can read the bar in a fraction as the word per. The example I used in the last video was if I'm driving 60 miles per hour, I can also write that in fraction form because the bar can be read as per, like this, 60 miles per 1 hour, right? So when I set up a rate, I can set it up as a fraction. 15 minutes per 3 shirts. Unknown, what do I need to find out? How long it takes her to do all 15 shirts. So let's look at how we do this. It takes, I don't know how many minutes to do 15 shirts. And it takes 15 minutes to do 3 shirts. So I set the 2 fractions equal to each other because the rate does not change. It's the same rate. This rate is the same rate as this. The only difference is I don't know how many minutes it takes to do 15 shirts. So then we're going to do cross multiplication like this, right? I don't know how many minutes it takes to do 15 times 15 over 3. Here we go. Let's do the math. 15 times 15 divided by 3 is 75. 75 minutes for all 15 shirts. Number 4. Allison and Robin each have a bag containing 20 marbles that are either black or white. The ratio of black to white marbles in Allison's bag is 3 to 2, and the ratio of black to white marbles in Robin's bag is 4 to 1. How many more black marbles does Robin have than Allison? Let's set up our known and our unknown. Known. I know that there are 20 marbles in each bag. I know that Allison has 3 to 2 black to white marbles, and I know that Robin has 4 to 1 black to white marbles. What I don't know, the difference between the black marbles. Why did I use this word difference? Let's look at the word problem. It says, how many more black marbles? Whenever you see this phrase, how many more, you should think to yourself in your head, oh, that means subtraction. I'm going to end up finding the difference, right? So the unknown, the difference between the black marbles. Allison and Robin, I set them up in opposite columns, and I'm going to work out the problem like this. Allison has 3 to 2. Let me do this so it's not confusing. Allison has 3 to 2 black to white marbles. Robin has 4-to-1 black to white marbles. Here's what that means. It means that for every 3 black marbles, Allison has 2 white marbles. In Robin's case, for every 4 black marbles, she has 1 white marble. So you need to ask yourself, because we have to represent this in fraction form, how many are in this whole set? 1, 2, 3, 4, 5. How many are in this whole set? 1, 2, 3, 4, 5. So 3/5 of Allison's marbles are black and 4/5 of Robin's marbles are black. The question is only asking about the black marbles, so I don't have to worry about the value I got for the white marbles because it's not asking me about that. Here we go. I'm going to change the denominator to 20 because there are 20 total marbles in each girl's bag. So how do I get from 5 to 20? Well, I have to multiply by 4, right? Whatever you do to the bottom, you have to do to the top. 3 times 4 is 12. 12/20 are black marbles. How do we get from 5 to 20? Once again, we multiply by 4. Whatever you do to the bottom, you have to do to the top. 4 times 4 is 16. 16/20 of Robin's marbles are black. But I'm not just finding the value for the black marbles. I need to find the difference in black marbles. So that's simple enough. 16 minus 12, 4 more black marbles. How many black marbles does Robin have? How many more black marbles does Robin have than Allison? 4 more black marbles. Number 5. The table below lists the top running speed in miles per hour for several animals. What is the median speed listed? This is part of data analysis supporting idea number 6. The median, we reviewed this right after spring break, and then we reviewed it again the following week, and there were still mistakes in this question. You need to remember that the median is the middle number in a set of numbers when the set is in order. This is the important part that a lot of people are still making mistakes on. When the list is in numerical order. As the list is now, that's not in numerical order, right? 43, 39, 9, 32, 11. Those don't go from least to greatest. They're all mixed up. A lot of you answered this question and you remembered the part about the median being the middle number, but you forgot about the numbers needing to be in order. So a lot of you answered that the median was chicken. That's not the median. It's the middle number in the way they chose to display the data, but that doesn't matter. I need to find the middle number when the numbers are in order. So I numbered these from least to greatest. 9, 11, 32, 39, 43. Now we can find the middle number. Let's block off these. I'm getting closer. I'm getting closer. 32 is the middle number. Number 6. In cooking class, Reuben made 50 sugar cookies. His teacher then asked him to decorate the cookies using different colors of frosting. Reuben decorated 15 of the cookies with green icing, 10 with yellow icing, 15 with red icing, and the rest with blue icing. What percent of the cookies did Reuben decorate with blue icing? Let's set up our known and our unknown. What do I know? 50 total cookies. I don't know what percent is blue. But I do know that 15 of these 50 are green, 10 of these 50 are yellow, and 15 of these 50 are red. Whatever's left over is going to be blue. But I'm not just looking for the number of cookies that are blue. I'm looking for the percent of cookies that are blue. This was the most common mistake in this question. A lot of you did your arithmetic correctly, but because you didn't give it to me in a percent, you got the question wrong. So let's see, the arithmetic was easy enough, right? Most of you got that part, right? 50 minus the 15 that are green, minus the 10 that are yellow, minus the 15 that are red. We end up getting 10 cookies that are blue. Some of you gave me an answer of just 10, but that's not what I need. I need a percent. So I have 10 cookies over 50 total cookies. We need to change this fraction into a percent. Whenever you change a fraction into a percent, you need to make the denominator 100. 50 cookies to 100. What do I need to do? I need to multiply by 2, right? Whatever you do to the bottom, you got to do the top. 10 times 2 is 20. So 10 over 50 is equivalent to 20 over 100. Now that it's over 100, I can give you the percent. It's 20%. Question number 7 was multiple choice. Which of the following numbers has a value greater than 3? I know that when a fraction is greater than 3, it's an improper fraction. Right here I see I have 1/3. That's definitely not the answer because that's a value less than 1. 16 over 15, that's an improper fraction, so that's possible. I'm going to keep that in there as an option. C says 3. I want a number greater than 3, so definitely not that. And 31%, remember, percents are always over 100. 31 over 100, that's a value less than 1, so it's definitely not the right answer. Just by the process of elimination and thinking about what makes sense, I would have got the right answer. But if you wanted to double check yourself and make sure you got the right answer, you could change this back to a mixed number. 5 goes into 16 3 times with 1 left over. 3 and 1/5 is a value greater than 3. So my answer checks out. I got it right. Number 8. It took Tony and Leanne 6 3/4 hours to paint the north side of their house on Saturday, from start to finish. About a half hour of this time was spent cleaning up, and they took 2 breaks that were 1/3 of an hour each. Which of the following is the best estimate of the time that was spent painting? Well, it takes 6 3/4 from start to finish. Half of this time, half an hour of this time, was spent cleaning up. So I know for sure the answer is going to be a value less than this, because they're telling me that half an hour of this time was spent cleaning and 2/3 of an hour were spent with a break. So for sure I'm going to end up doing some kind of subtraction here, right? A value less than 6 3/4. Already I can eliminate D as an option because that's greater than this. And I'm pretty confident I can get rid of C as an option too, because that seems too high to me. How would I end up with 6.5 hours if I'm already subtracting half an hour and 2/3 of an hour? Let's see. Now I narrowed it down to either A or B. Already you've increased your chances of answering this correctly. Let's look at our known and our unknown to begin. Known. I know that there are 6 3/4 total hours spent. Half an hour is spent cleaning, and it says they took 2 breaks that were 1/3 of an hour each. So 2 times 1/3 of an hour breaks. Unknown, the time spent painting. Here we go. 6 3/4 minus a half an hour that was spent cleaning, minus 1/3 break and another 1/3 break. Whenever we're subtracting fractions, we have to find a common denominator. The common denominator between 1/4, 1/2, and 1/3, I'm going to use 12. But before I do that, I got to change this back into an improper fraction. I can't have mixed numbers when I'm subtracting like this. So 6 times 4 is 24, plus 3 is 27. 27/4 minus a half, minus a third, minus a third. Now I'm going to convert everything to a denominator of 12. 27 times 3, because 4 times 3 is 12. Whatever you do to the bottom, you have to do to the top. 27 times 3 is 81. How do I get from 2 to 12? Times 6. Whatever you do to the bottom, you got to do to the top. 1 times 6 is 6. I need to convert thirds to twelfths. 3 times 4 is 12. Whatever you do to the bottom, you got to do to the top. Times 4, 4/12. Same thing here. It's just another third, right? 81 minus 6 minus 4 minus 4 is 67/12. To make it into a fraction, a mixed number, 12 goes into 67 5 times with 7 left over. 5 and 7/12. But it's asking me to estimate, right? And 5 and 7/12 is really close to 5 1/2. The answer was B.